Hey, hi. In our last session, we were discussing about what is subnet and how to calculate, I can say about the subnet calculations we discussed about. Okay, so we can perform the subnetting calculations based on the requirement of host and the requirement of networks. Okay, so these are the, like a small kind of formula what we need to remember. And this is the formula for how many, requirement of networks, how to calculate that. This is the formula for an example. Okay, and we gone through a couple of examples. One for like a FLSM, that is fixed length subnet masking. We discussed about that, and we went through one more example by using class B subnets by use. We need to have 500 hosts. Okay, how to calculate that? Okay, we discussed about all these things in the last session. Okay,
Yeah, okay.
so now in this session we'll discuss about what is OSI model. Okay, so OSI stands for Open System Interconnection. Okay, so like what, like it was developed in 1994 by International Standardization for Organization in 1994. So it describes how the data is transferring from one computer to another computer. Okay, so this OSI describes, okay, if you are sending a message from one to another computer. Okay, so how the data is going from here to here. Okay, so it describes about that, like a OSI model. And like this OSI model consists of 7 layers. Here each layer performs some specific functionality. So here we have 1 to 7 layers. So here each layer performs some functionality. Okay, so we'll discuss about like what are those layers, what the functions they perform, all these things. So as I mentioned, OSI layers having 7 layers. That is starting from application layer, presentation layer, session layer, transport layer, network layer, data link layer, and the last one is physical layer. So here, the first 3 layers, we used to call as upper layers or software layers, and the last, 4 layers, these are called, lower layers are hardware layers. Okay, so this first 3 layers, it deals with any application related issues. Okay, but in case of the last 4 layers, those are hardware layers, it deals with the data transfer related issues. Okay, so here we'll
Okay.
discuss about in detail about what is application layer does, what is presentation layer, all these things one by one. Okay, so let's start with application layer. So here like application layer, which is responsible for providing an interface to the users. Okay, suppose if you are accessing any website. Okay, so either you are accessing with with a browser, any browser, but while accessing that browser you are using like either https colon underscore google.com. So though you type google.com, but on the back end it will take as http or https colon double slash. Okay, so it provides some interface to the users to access something. So here if you are using like any browser. Okay, so suppose if you are using any application. Okay, so any application to send a messages, so it is providing some interface, right? Like to send and like receive the messages. Okay, so application layer responsible for providing an interface to the users. Okay, so here the services whatever it's running. Okay, so suppose if you take mail server. Okay, so it's run with some port number, that is 25. If you take like any browser. Okay, it will run with some service, that is https as a service. So here these services are nothing but it's a port number. Okay, so identification of services are done by the port numbers. So like what is port is nothing but it's a logical communication channel, and we have the port number starting from 0 to 65535 ports are there. So among 0 to 65535, they have categorized into 2 types. Okay, one is reserved ports or well-known ports, and another one is unreserved ports. So here the reserved ports are from 0 to 1023. Okay, those are called reserved ports or well-known ports, and anything above 1024, like it is called unreserved ports. Okay, so normally if you can see like any web application. Okay, so it runs with either http or https, if you observe in time. And sometimes like what they will do, if they want to protect more thing, then they will do https colon double slash google.com colon 8080, some unreserved ports also they will add. Okay, so it depends on like how they are configuring the application. And so if you can see here, like this it would be. Okay, by default this will be like that. Okay, if they want something to be like modified, or any special services they need to run, they will use this specific unreserved port on the last. Okay, so like here data transfer, it should be in plain text or encrypted format, because if you can see, if you are accessing any web browser, okay, you will get either http or https for any web browser. Okay, so if they are using http, then it's a plain text, and https it's a secure one, so it's an encrypted format. So like in the application layer, we have different protocols. Okay, those are SSH, Telnet, what is HTTP, HTTPS. So these are some set of application layer protocols. We'll discuss in detail about what is this protocol, what is this protocol. All these things we'll discuss in the next coming sessions. Okay. For now, what is application layer? It providing like which is responsible providing an interface to the users. Okay, and this is about in detail. Next layer
Okay.
is presentation layer. So any queries regarding application layer?
No, no.
Any questions?
Um,
Cool. So in case of presentation layer, what happened? Okay. So let me keep all these things, like, so that we'll go ahead. Okay. So here data, which is in the form of characters and numbers. So here we have application layer, first one, right? Application layer. Then second one is presentation layer. Okay,
Presentation.
so here, but if you are using any web browser or something, then the data will come to presentation layer. So here the data is in the form of like a plain text. Plain text is nothing but it's either ABC or 1 to 3 numbers. So what they will do, so like this, whatever the data it is there in the plain text, it will be converted to some encrypted format. That is like we can say a mission understandable language. Okay, so that is like ASCII to AB, some code it is. Okay, so we can say in a simple way, this plain text, I can say characters and numbers will be converted into mission understandable language. So the process of like this conversion from like characters and numbers to mission understandable language is called data translation. Okay, and one more thing what happened, so once you converted, okay, so if you are storing any data, it took some memory, right? So it
Yeah.
reduces the like memory also, it reduces the number of bits which is taken to storage. Okay, so like to represent the data, whatever bytes it is taking, it reduces the number of bytes so that it will transfer fastly. Okay, so the process of reducing the number of bits which is used to represent the data is called data compression. Okay, and so here we received the data, and which is converted to machine understandable language, and the size is reduced. And here, to provide like security, the data will be encrypted on the source end, and the data will be decrypted on the destination end. Source end is nothing but from where we are sending the data. So at that point of time, it will be encrypted, and while receiving the data, it should be decrypted. Okay, so
Okay.
we can say presentation performs three main functionalities. Those are data translation, data compression, and data
Data.
encryption and decryption. These are the three main functionalities of presentation layer. Okay,
Okay.
so let's go further. So next layer we have a session layer. So here what session layer do, like it will try to establish the connectivity between like communicating hosts. So here we have two computers when they're trying to connect with each other. Okay, so what session layer helps us, it will try to establish the connectivity between the other host where it is transferring the data, and it maintain the sessions also. So we can say it's establishing the connectivity, maintaining and terminating the sessions. It will be done or taken care by session layer. Okay, so here like before it is establishing and like maintaining the sessions, it performs authentication authorization. So authentication means whether we are sending to the correct device or not, and what type of authorization they're having on the data what we are sending. Okay, so that is called like authentication and authorization. Okay, so here session layer performs the main functionalities are like to establish maintain and synchronize the
Yes.
interaction between the communicating devices. Okay, so we can say like to establish and maintain the sessions between the two computers, the session layer, like it's a functionality. And what happens here, like it performs some other functionalities also. Those are session managing and synchronization recovery. So what is session managing? Suppose like you have a computer, right? And here we have browser. You are trying to access multiple websites on the multiple tabs. Okay, and the first tab you are trying to access google.com, and second tab some facebook.com, third tab some news, fourth tab some like some magazines you are reading. Okay, so here like it maintains the sessions, like when you are requesting from google.com, so you are receiving the response to only google.com page, right? You are not getting the other responses here, right?
Yeah.
So not only from computer, okay, take it from your mobile also. If you are trying to access something, like you in the browser, consider that it's a browser. Okay, so in the browser we'll be having n number of tabs. Tab 1, we are using google.com. Tab 2, something some. So here whatever the data you are I'm trying to access, it is landing the response to the same page, right, from where you try to access. Okay, so from here you're trying to access some other thing, that is like facebook.com you're trying to access. So whatever the request you are like requesting, it will get a response to the same tab where you are trying to access. Okay, suppose if you can say here, web browser opens a separate session. Okay, so for tab 1 it will maintain some separate session, tab 2 separate sessions. Okay, so and it keeps a track of which packet belongs to. So I mean at the end of the day, so though it's a browser, your data will go through only one point, right? You got my point? So though you are
Yeah.
trying to access many websites, okay, so you are trying to access with only one public IP address, na?
Yes.
So it maintains the like a track of which packet belongs to which connectivity, what you are trying to access. Okay, that process is called session management.
Okay.
Okay, and like what happened, like it added some synchronization recovery also. Like it is one of the action or the function which is provided by session layer. Okay, so let's see what is that. So here so the session layer adds some checkpoints when transmitting the data in a sequence. Okay, so the data will be sent in the sequence. Okay, so it adds some checkpoints. Okay, so whenever like some error occur while transferring the data, it retransfers the data from the checkpoints. Okay, so this process is called synchronization and recovery. Okay, so if you can say here, if any some other error occurs in the middle of the data transmission, then it
It retransmits. So
hello,
hello.
Ajiman, can you hear me?
Yeah, yes, I can.
Yeah, just a minute. Yeah. So like so we can say the functionalities of session layer is it will establish, maintain, and synchronization the interaction between the communicating devices, and it maintains session management and synchronization recovery. So these are the main functionalities of session layer. Okay, clear?
Yes.
Okay. So next layer is transport layer. So here whatever the data it is receiving. Okay. So here, it can mean like, it controls the reliability of the communication through segmentation, flow control, and error control. So what does it mean? We'll discuss. Okay. What is segmentation? What is flow control? And what is error control? So these are the three functionalities of transport layer. Okay. So let's see one by one. So here, segmentation is nothing but, like suppose you are sending the data. Okay. So application layer, presentation layer, session layer, then
Session layer,
and
transport
then
layer.
transport layer. So here while the data is receiving here, okay, suppose you are sending like hello, good morning, some message. Okay, so the data which is receiving to say in transport layer, it should be in the same size only, like same, it won't be divided. Okay, so here what happened, whatever the message we are getting, it divides into some small parts. Okay, so the process of dividing the message into multiple messages is called segmentation. Okay, so here if you can see the data before segmentation is hello, how are you? Suppose this message is sending. Okay, then what happening in the segmentation? it is dividing the message into multiple messages. This process is called segmentation. Okay,
Okay.
the process of dividing the one message into multiple smaller messages is called segmentation. Okay, so here whatever the data which is received from the session layer, it will be divided into smaller data units, is called segments. Okay, and here for each segment a number will be assigned. Okay, that is called sequence number. Okay, so let's see what is sequence number. So here the data is divided, right? Hello, how are you? This is the one message. It is divided into multiple messages. Okay, and for each divided message it will be assigned with some number. Okay, I'll tell you why we need a number here.
Okay.
So like sequencing means assigning a number to each segment while transferring the data is called sequence number. So why? Because okay, so suppose you are sending this message, and many people data is going through only one channel, and your traffic it has to reach in the proper way, right? Hello, how are you? Only it has to reach, not like how are you, hello. So it should be in the same format, right? What you are sending. So by using the sequence number, it will rearrange the data. Okay, or reassemble the data at the destination by using the sequence numbers. So sometimes what happen, let me tell you, in a simple way. Suppose you are sending a message saying that, hello, how are you? Okay. So there are many people who are sitting in the organization. Okay. So then what happened? The devices, the traffic will go to only one communication channel, that is hub or something. So here, so there is no guarantee that, only first packet will go first, second packet will go first, third packet will go next, fourth packet. Okay. So it will be, jumbled while transferring the data, traveling the data in the medium, that is cables or something. So then once it reaches the destination, by using the sequence number, it will be rearranged to hello, how are you again. Okay. So that is what sequencing and how it helps. Clear?
Yes.
Okay. And suppose we have many devices like computer A, computer B, and computer C, and these are connected to a network device. So here the data what we are doing, we are dividing this data into multiple pieces, right? So that process is called segmentation.
Segmentation.
Okay, and so once we are sending the data, there is someone to receive our data, right? So
Yeah.
consider that you are trying to access from A to A only, but different networks. Okay, so here what happened? So whatever consider it's a network A and network B. So these networks are connected with only single cable. Okay. So here A is sending the data, B is sending the data, and C also sending the data. Okay. So whatever the data it is there, it has to go through a single medium, that is cable here. Okay. So here if you observe, okay, from A one segment is sending, B some other, C some other. So all the traffic whatever it is reaching to network device from A, B, C, it will be jumbled here, right? It's not like
Yeah.
only first A data I will send, then B data, then C data. It's not like that. Okay, it is combining the data and it is sending. Okay, so here the process of converting multiple data streams into one data streams is called multiplexing. Okay,
Okay.
and whatever the data is receiving in the destination, it has to distribute to A, B, C separately, right? So here the process of distributing one data stream into multiple data streams is called demultiplexing.
Okay.
Clear? So here
Yeah.
again again. So whatever the data which is receiving here, okay. So this data it is divided into segments. The segments are transferred to the medium and which is receiving here, okay. And here this data will be reassembled to A. Okay. So this is what which happens in case of transport layer. So here
Okay.
so here multiplexing is a technique which is used to combine and send the multiple data streams into one single medium, right? So this is called
Yeah.
multiplexing, and demultiplexing is nothing but it separates a single signal into multiple signals, right?
Mhm.
So here this multiplexing and demultiplexing, it's based on two things. We have time division multiplexing and frequency division multiplexing. Okay, but it's not required. This is the things actually I can say. what is multiplexing, what is demultiplexing, what is segmentation, and like what is reassembling, what is sequence number. Okay.
Yeah, okay.
And in case of transport layer, one more thing what happens, it adds the port number to the data. Okay, so either TCP or UDP protocol. Okay, so we'll discuss about like what is TCP and what is UDP, all these things. So it adds some port number, whether it's port 80 or ports 443, all these things it will add here. This is about transport layer. Okay, so now
Yeah, okay.
the next layer is network layer. So here, whatever the data which is receiving from transport layer, so here this is the data. Okay, hello, how are you is the data. Okay, so like, I mean, though it's multiple signals, but consider this full data. Okay, and in transport layer it is adding source port and destination port. Okay, only port number it is
Okay.
adding here, source port and destination port. So this is from the transport layer. So then when it comes to network layer, what happened, it assigns source and destination IP address to each packet. So we were discussing, like in our last sessions, if any data which needs to be sent, okay, we need
Source
source
IP,
IP,
destination IP,
destination
source
IP,
MAC, destination MAC.
destination MAC. Apart from these things, we need to have source port and destination port also. Mainly, destination port is important. Okay, destination port is nothing but if you are trying to access any web browser, the port means it's service. It should be running on the server, right? Suppose you are
Yeah,
accessing web browser, so web browser works on service 443, so it should be running on here. Okay, that is the called source port. So it's a mandatory source port. It's just to track the sessions. That's it. Okay, there is no much important with respect to source port. Why it is like a constant port. So here source port, it should be any port. Okay, any random port it will take from 1024 to 65535. But in case of destination port, it should be constant. Okay, so here like in case of network layer, like in case of transport layer, it is added source port and destination port. Okay, and when the traffic comes to network layer from top to bottom, right, application layer, presentation layer, session layer,
destination layer, transport
transport
layer,
layer, and network layer
application
na.
layer.
So when the traffic coming from transport layer to network layer, what happens, it adds source IP and destination IP. So these two it is adding here. Okay, source IP
Yeah,
and destination IP to the data, it is adding here, source IP and destination IP. So here the combination of like these things is called packets. So we can say, if anyone will ask you, okay, in network layer, like what you call the data which is available there, so we can say it's a packet.
packet.
Data in the form of packet, we can say. Okay,
Okay.
and network layer is also responsible for routing, like the traffic between the networks. Okay, so here like we know, right, in case of network layer, we have the devices called router will be in the place. Okay, so what is the functionality of the router? So here we have a network A and network B and network C. So here router is there. Okay, so here the router functionality is to transfer the data to the multiple networks by using the IP addresses, that is logical addressing.
Addresses.
Okay, so that is called routing, moving the packet from source to destination, and it is based on the logical addressing. Okay, so suppose this is the source and this is the destination. Okay, we reach the router, and router's responsibility is to transfer the traffic to the intended destination, right? That is the functionality of the router, and that is what
Okay.
like moving choosing the best path to reach the destination is called path determination. So suppose like best path is nothing but like here you have the source and destination. Okay, so here like we have the router. Okay, and here we have one more router, and here it is reaching here. Okay, so what is the best path here? See here, these many routers it has to pass. Okay, but if you come in this way, only one router, right? This is the best
Yes.
path now. So like it will choose the best path while transferring the traffic. So the choosing the best path is called path determination. Okay, so
Okay.
what network layer does, it adds source and destination IP addresses to the data which is receiving from transport layer, and that is called packets, and it performs the routing and path determination also. So these are the functionalities of the network layer. Okay, and the next layer is here like we have some protocols, like in the transport layer we have TCP and UDP, right? So in the similar fashion, in the network layer also we have some protocols called, like static routes and dynamic routes. So here it is transferring the packet no by using the routing tables. Okay, so this routing table can be configured in two ways. Okay, that is static routes and dynamic routes. Okay, so we have like some other sessions where we'll discuss about in detail what is static route, what is dynamic route, all these things. But for now, like this concept will comes under network layer. Okay.
Okay.
So next layer is a data link layer. So here, like whatever the data we are receiving. So here the data link layer receiving the data from network layer, right? So in the network layer, we are having this information: data, source port and destination port, and source IP and destination IP address.
Destination.
So this is the data. So here what happens? Data link layer adds source MAC address and destination MAC address. Okay. So
Yeah.
this is called frames. Okay. So in case of network layer, this is called packet.
Okay.
In data link layer, we can call it as frame.
Frames.
Okay, so assigning of like a source MAC address and destination MAC address to the data which is receiving from network layer is called physical addressing. Okay, so next, like it provides error control and like a flow control mechanisms. So it provides the mechanism of error control which detects and retransmit the last frames. So if any data is transmitting, if any lost or damage happened to the frames whatever we are sending, it will retransmit. That is called error control. And next one is flow control. So here, like between the source and destination, the constant traffic it has to go, not it should be like a high sometimes, low data sometimes. Okay, it should be constant. Okay, so that process is called flow control.
To control.
And access control is nothing but like we having n number of devices, okay, which is transmitting the data. So which device has the control to transfer the data, that is called access control. Okay, so we can say data link layer performs the functionality such as physical addressing,
Everything.
error control, flow control, and access
Okay.
control. And the data which is available in the like data link layer is called frames. And
Frames.
apart from that, like so in network layer we have the like network devices, that is router, right? Router we have in
Yeah.
network
Yes.
layer. In the similar way, in the data link layer we have bridges and switches. Okay,
Okay.
and so these are the some protocols which is available in case of data link layer. Okay, we'll discuss about
Okay.
that in the later on sessions. So for now, what is data link layer and what is functionality? Okay, and next last layer is physical layer. Okay, so here physical layer like which is responsible for transferring the data between the networks. Okay, this is the last layer of OSI model. Okay, so here what's happening, like what are the data we are receiving from data link layer, that is frames, right? So these frames will be
Yeah. Yeah.
divided into like bits, okay, in the physical layer. And
Okay.
these bits while transferring the data, okay, depends on the cable which you are using. Suppose like between the source and destination. Okay, so if you are using like LAN cables we discussed, right? LAN cable, optical fiber cables, and air air means it's a Wi-Fi network. Okay, so if
Yeah.
you are
Yes.
using connectivity between like these two is a LAN cable, then the data will go through as electrical signals.
Electric
And in case of
signals.
optical fiber cables, it's a light signal.
Like
And in case of
signals.
air, it's a Wi-Fi, it's a radio signal. Okay,
Yes.
so it depends on the media what you are using. Okay,
Okay.
so like that the data transfer will go further. So here like we have something called bit rate control. So it defines the transmission rate. Okay, number of bits per second, how many number of bits it can be transferred over the media, that is called like bit rate control. Okay, and it provides like one more thing called bit synchronization. Okay, so bit synchronization nothing but it provides synchronization by providing a clock in the sense it's a kind of time it is. Okay, so based on the time
Okay.
it synchronizes the bits which is transferring over the data. And we have some things called like a transmission mode. Okay, so we have like a transmission mode such as like simplex and half duplex and full duplex. Okay, so these are transmission modes. Simplex is nothing but only one way communication. Half duplex only both can send, okay, source and destination, so only one can send the data in case of simplex. Okay, in case of half duplex, both source and destination can send and receive the data, but only one at a time. Okay,
Okay.
and full duplex, both at the same time they can
Both can
send and
send it.
receive the data. That is about transmission modes. That is simplex, half duplex, and full duplex.
Option.
Okay, so here in physical layer we have these network devices, that is hub, repeater, modem, cables. So these are the list of devices we have. Okay, so this is
Okay.
about like the OSI layers, how the each layer perform its functionality. Okay, so we have let's go through a small demonstration, like what happens if A and B is communicating with each other. Okay, suppose we have
No.
computer A and computer B. So here what it is doing, like just observe clearly what is happening. It's a kind of small animation it is. Okay, so sending
Okay.
hello message to B. Okay, then in the application layer what's happening, it providing an user interface to send the hello message. Okay, so here the data is hello, and next layer is presentation layer, right?
Presentation layer.
In the presentation layer what's happening, data translation, data compression, and encryption is happening to the data. Okay, and the next layer is session layer. So in the session layer, what's the functionality of session layer? It is to establish, maintain, and terminating the sessions. Okay, so these first three layers are deals with software related issues or application related issues. Okay,
Application.
and the next layer is the transport layer. So in transport layer what's happening, segmentation and sequencing is happening on the source end. Okay, and here we are adding source port and destination port to the data what we are sending. Okay, so here the data is in the form of segments in the transport layer. Okay, and the next layer is network layer. So in the network layer what's happening, the functionality of network layer is IP addressing and the routing, and it is adding source IP address and the destination IP address. Okay, so here the data which is in the form of packets,
Packets.
and the next layer is data link
Data.
layer. So in data link layer what's happening, physical address flow control and access control is happening. Okay, so mainly we can say source MAC address and destination MAC address will be added to the data link layer, like in case of the data. So the data which is in the form of frames.
Frames.
Okay, and the next layer is physical layer. So
Layer.
physical layer, like it's performing bitrate control and the bit synchronization, and it is dividing like the frames into bits. Okay, so this is what happen if you send a hello message, okay, to your computer. So next what happens, let's see. So if we have another device where we need to receive the data. Okay, consider that like these devices are connected with some LAN cable. Okay, so
Okay.
the data is in form of, if it is LAN cable, the data will go as
Electrical
like
signals.
electrical signals, right? So these bits will be converted to electrical signal while going the data to the other computer physical layer. Okay, so if you are sending a message, so your like a task starts from application layer. Okay, when you are receiving the message, it starts from physical layer. Okay,
Okay.
so in the physical layer again these signals will be converted into bits. Okay, and next data link layer. So here a source MAC, destination MAC, everything will be there. And when it's going through upper layers, like it will be removed here if you can see. Okay, so in the data link layer, source MAC and destination MAC, it is reached. Okay, and it is removed and it will transferring to the network layer with only IP address and port.
Okay.
And next layer is transport layer. So here what happening, so segmentation is happening, right, and sequence numbers. By using the sequence number, we are reassembling here the data.
Okay.
Okay, okay, so this is what it happens. And next layer is session layer. So like it's just to maintain and terminating the session only. Next presentation layer, whatever the data translation happen here, okay, from machine understandable, like normal characters and numbers to machine understandable language, right? So this machine understandable language again it will be converted to characters and numbers in the destination end. Okay, presentation layer. And then last one is application layer, the data. So here what's happening, hello message is received to the B. This is what happen if you try to access anything from either browser or any user interface. Okay, so here again we are having like we received hello message from computer A. Okay, and when it comes
Mm.
to the protocols which are using in the each application layer, in the application layer we are having this other list of protocols. Those are SSH, FTP, HTTPS, DHCP. There are many. Okay, like few of them I have mentioned here, but we'll discuss about like application layer protocols in detail in the coming sessions. Okay, and in case of transport layer, what we have TCP and UDP. And in case of network layer, these are the different dynamic routing protocols which are available in the network layer. And these are SDLC, HDLC, NCP, PPP. These are I can say the data link layer protocols which you use for switching. Okay, and then next one is bitrate control and synchronization. Okay, so this is about OSI model and its explanation. Okay, any queries or any questions?
Yeah, from the computer we like there also we will call like packets and frames.
Yeah, whatever. See, if the data is whatever the data it is, I mean, it is in the transport layer. That is segments only. So here
Yeah, okay.
in the network layer, packets, and here in the data link layer, it is a frame, and in physical layer, it's a bits. That's it.
Yeah, okay, okay.
Wherever the data is available in the layer, it's the same name. It is whether it is source or destination, it's the same name.
Okay.
Okay.
Yeah.
So in so this is like a most important thing, and with respect to firewall things, I can say. Okay, so firewall works on port numbers and IP addresses, right? Mainly, like
Yeah, yes.
the bare minimum firewall, it works on port numbers and the IP addresses. Okay, so we can say our work is mainly related to transport and network layer
Transport and network
in the
layer.
olden days. Okay, now
Yeah.
like what's happening in the next generation firewalls. Okay, so we are including like application layer protection also, everything. Okay, so we can say like with respect to each and every layer nowadays, as per the technology growing, okay, we are having the devices like that. Okay,
Mhm.
so in the bare minimum, we can say like which layer firewall is working. So we can say
Mhm.
is a transport and between transport and network layer or firewall is working.
Okay.
Okay, so any queries or something I can before
No,
ending
I'm
the session.
fine.
Okay, cool. Yeah, so far we discussed about the OSI model, and if any computer send a message to another computer which is in the network, this is how it goes. Okay, so from like a sending computer, it will start from application layer, and towards it will come to physical layer. Okay, and it will traverse through media, and when it reaches the destination, again it will start from physical layer to application layer until unless it is receives the data. Okay, this is about OSI reference model. Okay, which is very important one. And then we have one more model that is called TCP IP model. Okay, so here if you observe like a TCP IP model having four layers. Like there is one is application layer, another one is transport layer, and internet layer, and the last one is link layer. Okay, so here TCP/IP reference model is more or less similar to OSI reference model only. So here, if you can observe, okay, in OSI model we have application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. So here we have 7 layers, right? So whatever the functionalities OSI layer is performing, like it is similarly to the TCP/IP model. Okay, it's most it's like it's similar. I can say OS reference model and TCP reference model is more or less similar. Okay, so here the difference is okay. In OSI model we have like three different layers for application related issues. All these things, right? That is application layer, presentation layer, and session layer. These three are called like upper layer, and it deals with application related issues. Okay, so in case of TCP/IP model, we're having only one layer, that is called application layer, to perform the activities whatever here it's done by the OSI layer, application layer, presentation layer. These three will be combined as application layer. So here one know like here application layer, what is provide? It provides user interface, and in case of application layer, in the OSI model, and it provides and data translation, data compression, and encryption and decryption, and it maintains the sessions. Okay, so this is the functionality of application layer in case of a TCP/IP reference model. Okay, and the next layer is transport layer. Okay, so like a transport layer in OSI model and TCP reference model, it's both are same. Okay, so it's take care of like what I can say, like segmentation, sequencing, assembling, and reassembling on the destination end. Okay, and moreover here it adds the TCP or UDP source and destination port numbers. Okay, so this is about transport layer. And here, like in voice reference model, the next layer is network layer and data link layer. So what are the functionalities of network layer and data link layer? Okay, so here we have, in case of for network, layer in OSM model is called as internet layer in case of TCP/IP model. Okay, so in case of like whatever the functionality network layer is performing in OSI model, okay, same thing will be performed on the TCP/IP model. Okay, so here assigning of IP addresses and path determination, routing, it will all taken care by internet layer in the TCP reference model. And the next two layers are data link layer and physical layer, right, in the OSI reference model. So what are the functionalities these layers are performing? So it will be taken care by only one layer in TCP/IP model, that is link layer. So here, assigning of MAC address, flow control, error control, access control, and like a bitrate control, a bit synchronization. What are the things uh, the data link layer and physical layer performing in OSI model? Same thing, it will be taken care by link layer in case of TCP/IP reference model. Okay, so this is about TCP/IP reference model. So in a brief, we can say TCP/IP model and OSI reference model is one of the both are functionalities are same. In case of OSI reference model, we are having 7 layers, and in case of TCP/IP reference model, we have only 4 layers. Okay, so those 4 layers are application layer, transport layer, internet layer, and link layer. Okay, so the functionalities, if anyone will ask you what is the functionality of application layer. Okay, so if you remember the functionalities of application layer, presentation layer, session layer in OS reference model, same thing will be replicated here. Okay, and the transport layer both are same. And in case of in OS reference model, we can call it as a network layer. And in case of TCP/IP model, it is internet layer. Okay, and data link layer and physical layer is commonly called as link layer in case of TCP/IP model. Okay, so the functionalities are same, but the way of layering is different here. That's it. Okay, that's about a TCP/IP model and OS reference model and its comparison. Thank you.